Hello guys, welcome to my YouTube channel. So in this video, we are going to talk about outliers. So what exactly are outliers? So in statistics, outliers are data points that don't belong to certain population. It is abnormal observation that lies far away from population. So we can say it in this way as well that when you collect data, when you see data, there are some data points that does not look normal. Okay, something like that. Let's say an example of age. Age cannot be zero. Okay, it depends from domain to domain. Um, Age cannot be zero in if you are working in a product company, okay, or you are working in a like business firm. The age cannot be zero, or age cannot be like 150. That is not normal. Age above 150 is 100 is fine, but age above 150 is not normal. So those data points, we call it outliers. Okay, so how we can deal with the outliers? So first of all, either you can see it depends from domain to domain. There are some domains in these outliers are very important. Like if you talk about like fraud detection. Okay, if there is a credit card company and if you see a transaction of like a huge amount that is not normal according to that particular customer's history, so in that case, that outliers will help us to detect the fraud. Okay. So either we can either we can remove the outliers like in case of age, or we can use the outliers like in case of fraud card detection. So what are the options to what are the options to detect and remove outliers? The first of all, we have some things like we have plots like scatter plots, we have box plots that will help us to see the outliers in the data point. Okay, and in this video we are going to use the z-score and the interquartile range, okay, to detect and remove the outliers. So what is z-score? So z-score, guys, as you can see in a standard normal distribution, in the standard normal distribution, the our data points lies like in one standard deviation, in two standard deviation, in three standard deviation. Okay, let me show you from here. Hmm. Stand, Standard normal distribution. So here you can see that this is the first standard deviation. Okay, this is the second standard deviation. This is the third standard deviation. Okay, here standard deviation is zero. Okay, so anything lies beyond the third standard deviation is uh, third standard deviation is an outlier. Okay, so z-score does the same thing. Okay, so in z-score what we do, we x minus mean upon the standard deviation. So x is the data point, we subtract the mean from that data point and divide it by the standard deviation, and we get a z-score. And if the z-score is greater than 3, then it is an outlier. So let me show it with an example. You will see there is a I have created a list of data points. They are randomly, and I have included two outliers in this. See, all these data points are normal. 1, 2, 3, 7. Let's take it as a age in a hospital. Okay. But 200 to 1, it's these are not normal ages. So what are we gonna do? We're gonna create a list for the outliers to store our outliers in that. Okay, and we'll create a function outliers and we'll pass the data into that function. Okay, so limit is 3. This is the standard deviation. Anything beyond 3, third standard deviation, will be an outlier. So first we'll calculate of the mean of the data, standard deviation of the data, and for each data point we'll calculate the z-score. So z-score will be data point 1 minus my mean upon my standard deviation. Now, if NP of absolute zero passes a positive value is greater than threshold, that is 3, we're gonna append it to outliers dot append I, return outliers. So we're gonna store it in a variable. We'll call the function. We'll call the x into that, and we can see. we got outliers 201 and 202. We can remove those outliers. This is in a shortcut to calculate the z-score as well. To calculate the z-score, we have a very good library in the Python, that is scipy.stats. From scipy.stats, we're gonna import z-score and we're gonna pass the data set to that z-score, and here you can, if we call it, and you can see the last two data points that they are more than 3. So in this way, we'll use the z-score to calculate the outliers. So now we're gonna talk about the IQR interquartile range. So this is a box plot, guys. It looks like this. Okay, and anything beyond these two lines, these small circles, are outliers. Okay, so this is called a lower bound, and this is a upper bound. This is the median. Inside the box you will see a line. This is the median, and the end of the boxes, that is q1 and q3. Okay, and these are the lower bound limit. Anything beyond, anything lesser than lower bound is an outlier. Anything greater than the upper bound is an outlier. This is an interquartile range. This is an interquartile range, IQR. So for that, we're gonna, so I will create a box plot for the same data set. I'll call the c1 library, and we're gonna create the box plot. So here you can see this is an outlier. So it might be 2 because there we have 201 and 202, but they are very close, so we cannot differentiate between the data point. So first of all, what we do, we just sort the data points. Okay, so I have just sorted the data point, and so first of all, let me show you how the IQR range. So first we have this data point 1 2 3 6 and 200 and 1 2. So first we'll sort the data. Okay, we sort the data, and we'll get a median value. Let's say 12 is the median value. So now we'll get the quartile one. Okay, quartile one, the upper, we calculate the median again for this. If it is 6, okay, that is q1. And for the lower bound, for the beyond 12, we get a middle, let's say 46. So 43, and here if we get a 5, so this is my q1 and q3. Perfect. So now we're gonna use numpy array function, that is first we'll create two variables, quantile 1, quantile 2, and we'll gonna call np dot percentile. We'll pass the data and we'll calculate the 25 and 75 percentile. Okay, so quantile 1, it is 6, quantile 3, it is 33.5. If you want to calculate the IQR range, so q3 minus q1, we got IQR. So now we want to calculate the lower bound, that is the this line. Okay, so for that we have formula q1 minus 1.5 times of 1 point IQR, and upper bound is 1.5 times of IQR. So if I see at anything beyond minus 35 is outlier, anything greater than 74.5 is outlier. So if we call x greater than upper bound, we'll got the last two value true. Okay, upper bound. But if we call, we'll got let's call mm, x less than lower bound, and all the data points are true here, false here. Okay, so there is no value lesser than the lower bound. And again we have a, we're gonna use again alternative method, the scipy library. From that we're gonna call it IQR range from, and we're gonna pass the x with the range 25 to 75, and we'll get 27.5. So in this way we calculate the IQR range, and we'll use it to calculate the lower bound and upper bound, and anything lies beyond those lower bound and upper bound are called outliers.